All right, and we are live. It's great to be here. We're trying something new this time. We're streaming in multiple places, so across LinkedIn, YouTube, and of course Crowdcast. Crowdcast is the main platform. So if you want to participate, then make sure that you head over there. I'm just hearing myself multiple times, so I'm fixing that up. All right, we're good to go now. I can remove my stream starting soon banner because we've started. So welcome everyone. I'm so excited to have Tiexin with me today to do this webinar on Kubernetes security. We had just over 660 registered for this event, so it's the largest webinar that we've done so far. So very excited to be able to get into this. So let me get started in here. I'll go to the side. All right. So just a little bit of an introduction as to what we're going to be doing today. So we are going to talk a little bit about what is Kubernetes, making sure everyone's up to speed, and then we're going to bring in Tiexin, who I'll introduce shortly. We're going to talk about various security topics. Now, we have a lot to try and back into one webinar, so we're going to go through a lot. But I just want to say, I'll share some links as we go with this to help you. So there's a bunch of tutorials. Everything that we're going to talk about is covered in articles that will be free. You'll have access to. So today you can ask questions. You'll be able to watch this webinar again, and you'll be able to go through step by step of everything we talk about in some articles and tutorials that I'll share with you throughout the way. But we're going to talk about threat modeling. We're going to talk about pod security, network security, authn and authz, and you're going to have time to ask questions. So I'd really take advantage of that. I'm not going to be able to answer much of them, but Tiexin is an expert, and this is a rare opportunity to be able to speak to someone like him. Of course, we have prizes, as always. We have some swag bags for sale, not for sale, to give away. We have swag bags to give away, so participate in that. We've had some issues shipping the last swag bags, but they're out today. So I apologize if you won one last webinar and you hasn't received it. I promise it's in the mail. But this, if you want to win a swag bag, we have Rubik's Cubes. We've got some caps. We have some cash cams in those. Make sure you participate. Participate in the chat. Participate in the polls that are coming up. Ask questions. If you're in Crowdcast, which is the main place that you'll be able to ask questions, then there's a bottom at the bottom that says ask a question. So please go ahead and use that, and we'll get through to them at the end. So while we're waiting for everyone to join, let me know where you're joining in from. So Tiexin, whereabouts are you joining us from today?
Today I'm joining you from the central part of China. Yeah.
Central part of China. I would ask what city, but my Chinese geography is severely lacking, I have to say. I'm in Paris myself at the GitGuardian headquarters. We're moving office soon, but yeah, looking forward to seeing them. All right, have some people from Florida. Great things. Miami, be a bit warmer in Miami than where we are right now, I'm sure, for sure. Some more in France. Welcome, New York, Lagos, Houston, Nottingham, Belgium, Egypt, Colombia, France, Poland, Ethiopia. Wow, we're getting some great ones today. It's so cool to see everyone tuning in from all around the world. All right, let's get stuck in. So, quick poll before we get started. In the poll section, you'll see this here. How do you currently use Kubernetes? Are you running self-managed clusters in production? Are you using a managed cloud provider that helps with that? So, for example, AWS Elastic Kubernetes Service, I think it's called. Are you just getting started with Kubernetes, or do you have absolutely no idea what this terrifying name is? Let us know on the poll, and we'll get back to that in a minute. But right now, I'd like to introduce the man of the hour, Tiexin. Tiexin was formerly worked in AWS. He is a man of many traits. We've been working with Tiexin for over a year. I read some of his blogs and I begged him to write for GitGuardian. And so he's written some great articles for GitGuardian, which are all available on our blog. But he's also working on some other projects. So Tiexin, could I invite you to talk a little bit about yourself, some of the cool projects that you're working on at the moment?
Yeah, sure. Okay. Basically, during the past 5 years, I was basically working and living in Germany, Munich to be specific. I just moved back to China because of the COVID situation, and I could never go back. Yeah, too bad. Yeah. I was working as AWS senior DevOps consultant, but I've been doing different jobs recently. Yeah. After I left AWS, I joined the Huawei Cloud, leading a 300 people team about developing efficiencies and quality, stuff like that. Yeah. But I'm pretty sure you understand because of the big corporation bureaucratic stuff. That's why I left. Now I'm working on an open source DevOps toolchain manager project. Yeah, completely free. It's called DevStream. If you're interested, maybe you can check it out. Yeah, and I also write some blogs on Medium. Yeah.
Yeah, definitely follow Tiexin on Medium if you can. He also writes for the GitGuardian blog, so you can follow him there,
sure.
Which is a great place. And that DevStream is posted below there too. So I'll definitely check out that project and give it a star because it's definitely worth it. All right, let's get stuck in to the subject matter. Tiexin, what is Kubernetes? Can you explain a little bit about what this technology is, and some anecdotes around about that?
Okay, so in general, Kubernetes is containerization orchestration platform. It has been around for almost 8 years, I would say. But during the past 2-3 years, I think it has risen drastically in popularity in the past 3 years. Yeah. But I think this quick introduction probably doesn't tell you much. So maybe let me tell you a story of myself. 12 years ago, I was working at Baidu, which is the largest search engine company in China. It's a Chinese equivalent of Google. But because there are so many population, there are also a lot of requests. We were doing a lot of different services, some of which were getting like over 1 billion requests per day. So apparently one host cannot handle all the requests. So we have to spin up a lot of instances to share the load. So we have 2, 3, or even more. That's why we need some load balancing. Back then, I believe the term microservice hasn't even been invented yet. So we have to do everything manually with the views we invented ourselves. There is no tool for doing this. And because we have a lot of instances, we also have to worry about, for example, automated failover, redundancies, stuff like that. So basically, these are the things you will need once your business scale to a certain extent. But luckily, nowadays we have Kubernetes. It can orchestrate our containerized workload automatically for us. It reduces our manual operational overhead so that we as developers, engineers, have time and energy to focus on more important things. So that's what Kubernetes is to me. Yeah.
Yeah, that's great. You know, it's funny. There's so many people that we don't even understand the pain of what it's like. I've personally never had to deal with a server rack or anything like that. So it's going back and how fast we move. And Kubernetes is such a powerful tool now in dealing with that. So why should we care about Kubernetes and security in particular? So what are the difficulties in Kubernetes that we need to deal with?
I think it's because Kubernetes as a very complicated platform. It's not so easy to set up correctly and run fluently without any issues. There are multiple components in Kubernetes, and it's fair to say that every component is actually quite critical. So there is a learning curve, and the learning curve is actually not so flat. It's quite steep. That is why I think there are so many data leaks or hacked clusters due to misconfiguration, for example. Yeah.
Definitely. Okay. So what we're going to talk about today is really going to come from recommendations that have out of two American agencies. So we have the National Security Agency, the NSA. I'm sure if you've watched any Hollywood movie, you'd probably know about them. But they have a huge cyber division as well, and also the CISA, which is a Cybersecurity and Infrastructure Security Agency. Now, what's important is that these agencies have published guides about how to kind of achieve that military grade best practices in Kubernetes security. These form the foundation. Now, we wanted to write an article about that, and Tiexin is our go-to when it comes to complicated topics to be explained adequately. So we tasked the process here with Tiexin to be able to do this, and this is the guide that we're going to be using throughout this. So it's been a long process to put this together, and those articles are available on the GitGuardian blog. If you go to blog.gitguardian.com/Kubernetes, then you'll be able to find all of those articles there. But this webinar is going to cover a lot of that. So let's talk about the Kubernetes components. Tiexin, can you explain how Kubernetes fits together and the components that make up that?
Okay, so actually I checked the poll just before. So I think most people actually do have some background knowledge regarding Kubernetes. So I will not explain too much into detail. But in general, Kubernetes is made up of two parts. One is the control plane, which is the rectangular on the left side of the picture, yeah. And another part is worker node on the right side. So control plane, actually, it makes global decisions, I would say, for the cluster. For example, scheduling some tasks, right? So basically, the control plane detects and responds to cluster events. For example, when you spin up a new pod, there will be an event, and it's the control plane's duty to actually decide where to schedule the pod to run. To do that, control plane has actually multiple components. The very first and the most important one is a Kube API server, which is the one in the very center of the rectangular. Basically, it works as the front end to the Kubernetes cluster. Basically, it exposes the API, defines what you can do or how you interact with the cluster. And since this is a front end, actually, etcd is the storage or the backend part of it, which is a key value store, which stores all the information about the cluster. As aforementioned, we have some scheduling to do, and that is the job of Kube scheduler. Basically, it will select a node for a pod to run on. We also have a bunch of controller managers. Actually, it's not just one controller manager, but multiple ones. Different controller managers are in charge of different things. For example, there is a node controller manager, which manages the node, as the name suggests, right? There is also an endpoint controller manager. Yeah. Last but not least, I want to mention the one on the upper right corner, which is a cloud controller manager. Because since we are all, well, not all, but many of us are running our clusters in a cloud provider, public cloud services. So we do have this cloud controller manager which interacts with our cloud. Basically, when you need a storage, when you need, for example, a load balancer, this is what the controller manager does. Yeah. That wraps up the control plane part. Then let's move to the right side, which is the worker node. Worker node, there can be multiple ones, of course, but there are some common components which are deployed on each node. For example, there is this kubelet, which works as an agent that runs the pod, right? To run the pod, you also have the container runtime, Docker, containerd, etc. We also need a kube proxy on each node, which works as a network proxy. It defines rules on each node so that the network traffic communication is allowed to the pods. There are maybe a few other components that is not in the picture. For example, we also have a cluster DNS, which is in charge of resolving the internal DNS records. Basically, that's it. Yeah.
Okay, great. So that just kind of brings everyone up to speed of some of the components of here. So now that we've kind of got a bit of understanding, let's get into some of the security components of this. So the first step we have here is the threat model. So what is threat modeling and how does it relate specifically in Kubernetes?
Okay, so basically threat model or just any model is just a way to model stuff so that you can have a better understanding of it. In this instance, we have this Kubernetes threat model, and there is not a single model that defines everything. We have multiple ones, of course. For example, if you guys are familiar with the CNCF, there is one specifically for financial services related projects, right? But in my case, I'm using a model more or less of myself. And this model is made up of three major components, I would say. First part is a supply chain risk. Second part is malicious actors. And the third part is insider threats. So let's talk about the first part first. Basically, what supply chain risk means is software risks or dependencies risks. Nowadays, we have a lot of common vulnerabilities and exposures, right? And we have it in both containers and softwares as well. Since we run our workload in containerized pods, our Docker container has third-party libraries. If there is a loophole in the third-party library, it can be exploited. And on the node, we have software dependencies, stuff like that. And they also have common CVEs as well. So if a hacker manages to get into the node or manages to use one of the common CVE of a certain dependency or software, it can actually get access to everything. So basically, this is a supply chain risk. Of course, there are CVEs, but if there is nobody trying to exploit those CVEs, it's actually not that bad, right? That moves us to the second part, which is the malicious actors. We have hackers around the world, which are trying to find vulnerabilities of our cluster, trying to get access into our cluster, our workload, our pod, our node, right? Besides vulnerabilities, there are also configuration issues. Because we already mentioned there are multiple components of the cluster. Each component requires a specific configuration. So even if there is a single misconfiguration of a simple component, can have like tremendous consequences. That is the malicious actors part. Sorry. Last is insider threats. Basically, this is what the authentication does. For example, even if we're deploying our clusters in cloud providers, for example, in AWS, right? There are still people who actually have physical access to the data center, to the hardware. They can be insiders. And if we are talking about different types of users, we have administrators, normal users, stuff like that. And admins may execute any command in containers. Even if we have like role-based access control configured, they can be misconfigured because it's complicated, right? So internal people can actually exploit those loopholes as well. Yeah, basically that's Kubernetes threat model. Yeah.
All right. Okay, that's really interesting. But now let's get stuck into the meat of this with some practical examples, code, and seeing how we can secure our Kubernetes clusters. So let's start with pod security. Now, I think that this is one of the the most one of the most important aspects of what we're going to talk about. So let's start. And what is pod security, and what are some of the core things that we need to focus on when we're securing our pods?
Okay, sure. Yeah, I totally agree. Pod actually is the most important stuff in Kubernetes because it's the most basic building block of everything. Of course, there is container or containers in a pod, but probably cannot run that directly. So pod is like the basic building block. If we can secure pods, probably we are already 50% down regarding the security issues. And for pod security, I think there are four components I want to talk about. First is running pod as root, or rather not running pod as root. Because every container is actually just a running process. It is a containerized process, but it's just like any other Linux process. It uses system calls and it needs permissions. And that is why all the traditional like Linux stuff, like syscalls, namespaces, control groups, permissions, capabilities, they are all related to containers. Actually, that's bad because by default, many container services, they run as privileged root user. So if the process has root privileges and gets exploited, you are basically giving the root access to the hacker. That is why preventing root execution by using some non-root containers is crucial. Yeah.
All right. So we have here, obviously, looks like a Docker image. Let's talk about what we can do to prevent containers running as root. What are the steps we can take?
Okay, sure. Basically, on the upper right, this is a very simple Docker file. It doesn't do much. I think most people probably understand. Yeah. But by default, this Docker container will run as root user, and this is not safe, as explained. There are actually 2 or 3 things we can do. Here, let's address 2 of them. One is the Docker file user instruction. We can specify in the Docker file user ID, then group ID. In this case, we tell the Docker under which user we want to create this Docker container process. This is one way. So if you forgot, I think that's bad. We need to make this as a best practice. Follow this idea, right? On the other hand, we have the security context in Kubernetes. When we define the pod, we can have this security context defined. Here you can have multiple values. But for example, the most simple and probably mostly used one is run as non-root. Let's make it true so that if the container runs as a non-root user, it cannot be created at all. Yeah.
Okay, yeah, great. It's very clear. So moving on, we have the immutable file system. So using this wherever possible. Can you explain what that is, why that's important, and then we'll get into some code of how we can implement that.
Sure, yeah. The second part I want to talk about is file system. So by default, containers are permitted mostly unrestricted. They can do any execution within their own context, which means they can probably save something into the file system. If we use a read-only immutable file system, right, it helps to enforce immutable infrastructure strategy. The container should only write unmounted volumes that can persist, even if the container exists, right? Maybe let's have a look at an example. Yeah. On the right side, I'm pretty sure most people have done this when you try to do some debugging in Kubernetes, right? We run kubectl exec to start a shell and get into the container and do some debugging stuff. For example, maybe we need to create some files, or we need to change some source code. Maybe we even need to run some command and download some packages, stuff like that. Yeah, just like the example shows. But the thing is, a hacker who has gained access to this container can also create files and download scripts and modify your applications or source code within the container, just like what we did when we were debugging, right? That is why immutable file system is important to most containers, because actually a lot of containers don't really need to write the root file system. For example, if we are just building a web application, we don't really need to write something to the rootfs. It's also a good practice to enforce the read-only rootfs as true. Yeah. Okay,
so now image scanning. We've talked about this before, right? Because of GitGuardian, we can scan Docker images for secrets. We have a webinar on that too. You can check that out in the archives. But we're going a bit further than that. We have a tool here, an open source tool that you're recommended. Why should we scan our images and what further should we do from that?
Okay, so since we're talking about pod security, we have to talk about images, because images are the base on which pods are created, right? Mm-hmm. If we talk about the images, basically there are 2 ways to create them. The first approach is to build it from scratch. but we really don't do this very often. The more common way is to build a Docker image on top of existing one. For example, in the previous example, we have from something. The from something is a base image. Since we are using a base image, which means we are using someone else's image, we must use trusted images from trusted repositories. We cannot just use any image out there. And even if we are already using a trusted resource, we still need to scan it because maybe the base image has some known CVEs. That is why image scanning is also crucial to pod security. Of course, there are, sorry.
So I was just going to say, and when should we do this image scanning? Is it something we need to automate? Is it something we do manually? Is it something, how do we set up secure image scanning?
Yeah, actually, we have multiple ways to do this. Manual locally is always possible, right? But it's not automated, which means we have some manual overhead. So we can integrate with our CI/CD systems. Besides CI/CD, there is also a Kubernetes admission controller, which is a Kubernetes native feature. It actually intercepts and processes requests to the API calls before the execution, which means before the pod is created, we can do something. And if this something scans the image, it enhances our security. Yeah.
Okay, great. All right, so let's talk about the pod security policies, PSPs. What are these? Should we be using them, and should we continue to use them in the future?
Okay, that's actually a great question. So what is PSP? Basically, this is what the name says. It's pod-related security policies. It has a lot of features. For example, you can deny a pod that runs as root. In the previous example, we mentioned how to use the user instruction and the security context to decide under which user the container is running. But it's not actually enforced. For example, if I forgot to write those, or even if I don't really want to write it, we can still run it as a root user. But the PSP can be enforced. It's an enforced policy. We have other features, for example, run as a specific user, run as a group, allow privilege escalation, and etc. Yeah. But actually, there are a lot of usability issues with PSP because it's actually quite confusing. As shown here, it's complicated, right? It's easy to go wrong. And when it goes wrong, it's really hard to debug. In order to improve PSP, there must be some breaking changes. And I think that is why PSP has been deprecated last year in the 1.21 version. At the moment, you can still use it. And actually, it's still recommended to use it, but it will be removed in 1.25, I believe, probably 3 to 6 months from now. Yeah.
Right.
What replaces the PS? Yeah.
No, continue. Sorry, Tiexin.
No, I mean, I want to talk about the replacement for PSP because Kubernetes is releasing another stuff which is called Pod Security Admission Controller. It's already beta in the current version, and out of the box, it already meets the most common security needs. So basically, it's a much easier to use version of PSP. And there is an official way to migrate from pod security policy to the pod security admission controller. Yeah. But because it's still in beta, today we will not talk about it too much. Yeah.
Okay, so we should still be using PSPs today as a best practice, but know that it has been deprecated, and there is a solution that is less convoluted, let's say, coming up. Important
definitely, yeah.
All right, so we've come to the end of pod security, so we can kind of move forward now onto our network settings. So what is it about the network? What are attackers looking for in network vulnerabilities? Let's start there, and then let's get into some individual examples.
Okay, this is because actually all the components and the control plane and the nodes, they communicate over the network. That is why network security is crucial here. We don't really access a component directly. We access the Kube API server. and API server accesses other components. It even calls different nodes, stuff like that. Yeah, that is why network security is crucial to Kubernetes. Here, I think there are a few things to talk about. For example, we need to deny some unnecessary access to the control plane, to the etcd. If you are using a managed service Kubernetes, maybe there are some things to do. If you are using a self-managed Kubernetes cluster, you can also use for example, security groups to regulate the network traffic. Yeah.
Okay, so let's start. Denying access to the control planes of nodes. In this example, using a managed control plane. So we're using a managed service like AWS Elastic.
For example, in AWS EKS, Elastic Kubernetes Service, we don't really own the control plane, but rather it's a service out there. But still, we can define a security group around it, and we can define what the security group allows, which port you can listen to, stuff like that. Also, if you have multiple clusters, for example, you can use different security groups for different clusters so that there cannot be any overlapping between unrelated clusters. This can be a best practice. Yeah, we have a few maybe later. Yeah.
Okay, so let's talk about self-managed Kubernetes now, and what we need to talk about. And we have some ports here. Just something quickly that we need to worry about when we're doing self-managed clusters.
Yeah, exactly. I think at the moment there are multiple ways to create a self-managed cluster yourself. For example, we can use Terraform, we can use AWS EKS CTL. If you're using other cloud, there are always another option, right? There are even companies who installs Kubernetes clusters as a living. There are different ways, but there are some common practices to share. For example, we have some common ports as shown in the table below. The control plane, different components listens on different ports. So we can use the security group to allow only certain ports to be listened, and that's it. So that we don't increase the attack surface. I mean, if we expose some random ports or unnecessary ports, this increases the chance that a hacker, maybe he can get into it. That is an extra thing to consider if we are managing the control plane ourselves. Yeah.
Right. So we have some ports here from the control plane, and then also some ports here from the worker. And basically we want to limit access to just these ports for obvious reasons, right? We don't want to allow multiple gates into our area.
Yeah, exactly. Because the control plane is like the core part, and the worker node is actually handles the workload. If we get access to the worker node and we are not limited by any security group, any ports, dangerous things can also happen. That is the reason we also need to limit network access to the worker nodes. Yeah.
Okay, so let's talk about namespace separation. So maybe for people like me, who aren't super familiar, what is a namespace, and then what is namespace separation?
Okay, so a Kubernetes namespace is actually the way to partition the cluster resources among multiple individuals or teams or applications within the same cluster. Some people try to do this to achieve like a multi-tenancy. We have different tenancies inside the same cluster, which are separated by namespaces. So, for example, in this picture, we have two namespaces, and inside each namespace, we have different services and pods running. The thing is, by default, the namespaces are not automatically isolated. But we can achieve this by using network policies, which I believe is in the next slide, right? Pods and services in different namespaces can still communicate with each other, unless another additional separation is enforced by the network policy. We have an example of the network policy code on the next page. Yeah. Basically, network policy controls the traffic between pods and namespaces and even external IP addresses like that. By default, there is no network policies applied to any pod or namespace, resulting in unrestricted ingress and egress traffic within the pod network. But for example, if you have two namespaces, like the previous example, and you want to separate those two namespaces, we can use network policies to achieve this. I believe this is the only way to truly separate network traffic between namespaces and to achieve multi-tenancy inside the same cluster. Yeah.
All right. Now this is a slide that I like. Secrets management. So everyone that knows GitGuardian knows we're all about protecting our secrets. So how does this relate and translate into the workspace of Kubernetes and specifically network security? What are we looking for in protecting our secrets in this environment?
Yeah, basically secrets store like important stuff. That's why we call them secrets. But the thing is, secrets, they are stored in the etcd. And inside Kubernetes, they are stored as base 64 encoded format. It's not encryption, but rather encoding, right? If we are using Kubernetes as a service, for example, AWS, EKS, the chances are all the etcd volumes, the etcd backend storage volumes, they are already encrypted at the disk level. So basically, this is the data at rest encryption. But if we are deploying our own Kubernetes cluster, this is also configurable. We need to pass some argument so that the encryption is enabled by default. And since I think to encrypt the disk, to encrypt the volume is not enough, because secrets in Kubernetes cluster are just base 64 encoded. If you can read it, you can read it, right? Everybody can read it. And when the secrets are created in the first place, it's highly likely that we are creating those secrets with some YAML file. So we have to put the clear text into a file. And what do we do with the files, right? After the secrets are created, we delete them. What do we use? I mean, how do we share the secrets across teams and individuals, right? And I think this is where the secrets managers actually come to help. It acts as a single source of truth, where you store all the secrets encrypted. For example, HashiCorp has Vault, right? AWS has the secrets managers, and there are other equivalents as well. By using those secrets managers, we can actually store the secrets in an external secrets manager, make it much safer. And when we are launching a pod, running a workload, we can always use the secrets directly from those secrets managers. There are different ways to use it. Yeah, this is one way. Another way I want to mention is the external secrets. Basically, it allows you to use external secrets managers, but use it in a Kubernetes native way, so you don't have to change much. Yeah.
Right, got it. And just mentioning again, that if you want to check out the tutorials and stuff, you can go to blog.gitguardian.com/Kubernetes, and you'll see Tiexin's articles in here. We this morning took some out of the webinar because we wanted to kind of like talk about how to set up this, but it was too much for this webinar. But Tiexin has written some great examples of using external secrets here, their project, and added an example. So if you want to learn more about that, definitely check out those articles and tutorials there. But let's move on away from network. This is our last subject, authn and authz. So can you speak a little bit, Tiexin, about what these are? To start with, and then we'll dive into some of the security measures that we need to take around them.
Okay, so basically authentication and authorization handles the insider part of the threat model. Inside Kubernetes, we have different types of users. For example, normal user accounts, and we also have service accounts. And the service account actually is quite dangerous because if we authenticate with a service account token, it's actually very dangerous because the service accounts handle API requests on behalf of pods. If we have the token, basically we can do everything. In my article, actually, I have a very hands-on example where you can follow and experience it. When you have the token, you can basically access the Kube API. and everything. Yeah, that's why authentication and authorization is very important. Since we're on the topic, rule-based access control is also quite crucial here. We also need to use the least privilege principle. So we don't give more principal than needed to a certain user or to a certain group of users. If we are using like Kubernetes as a service, for example, using AWS EKS, there are a few best practices to follow as well. For example, maybe we can make the cluster endpoint private wherever possible. If we don't have to access endpoint from a public internet, we can always make it private. We can also use dedicated IAM roles to create clusters. We can also use IAM roles to authenticate like normal real users. And yeah, stuff like this. Oh, I think I cannot hear you.
Oh, sorry. I have a on-off switch on my microphone there. It was off. Sorry. So let's talk about some user types here. So what can you talk about the Kubernetes user types, and what should we be doing in terms of security?
Basically, there are two types, like normal user and service accounts. I think the key takeaway here is not to use the service accounts token to do anything, because that's dangerous, as explained. Yeah.
And we talked about the principle of least bridges here. So obviously important to continue with that.
Yep, we already covered this part briefly. And
okay. Well, let's move on to the last section that we have here: logging and auditing. So Kubernetes logging. Where's the security vulnerability in that, and what process does auditing take in terms of Kubernetes and security?
Okay, so auditing actually it provides a security related chronological set of records that documents the sequence of actions in a cluster, right? That is why we need the auditing. The cluster audits the activities generated by users, applications that use Kubernetes API. It also monitors the control plane itself. We also have audit policy, which defines different rules about what events should be recorded and what data should the record have. We have different examples in our articles as well. Yeah, but regarding logging and auditing, there are not too much to-dos, right? There are basically only two action items. First is enable it, because it's important. And the second is enabling it alone is not enough. We also need to regularly audit it. We need to regularly audit who has access to what. And there are some tools which can help us to do this. For example, we have a tool called kubectl who can. It's a command line tool. I believe it's open source as well, free to use. You can run the command and see who can do what with just one single command. There is another one which is great, RBAC lookup. Basically, it does checks or queries on different verbs and different things. It shows different role-based access control policies, so that we don't have to write a lot of kubectl commands to get the roles, to get the role bindings, to get cluster roles, stuff like that. Yeah.
Okay, great. So everyone get all of that? So Tiexin, thanks for going through that. Now we're going to go through and have an opportunity to ask some questions. Of course, I know that this is a lot to take in. We purposely kind of kept things at a high level with some examples, but we do have those in-depth details where you can work through. Tiexin has code examples and pull requests to help you do that. Tiexin, before we move on to the next section, which is we're going to ask some polls and get to some questions. What, for people that are actively using Kubernetes in production, whether they're managing it themselves, whether they're on using a service like AWS, what is important? What are some of the key areas from everything that we have just discussed? Where do we start with security, and how do we know? How do we know that we're keeping up with everything in security? We haven't planned this question, so I'm throwing you in the deep end here.
Okay, sure. Yeah. I think this is actually a very broad question. It's very good and it's difficult to answer because Kubernetes is too much. It's a lot of things. So I would say first, stop worrying too much. If we think about everything, maybe we cannot achieve anything, right? So basically, pick a point. Maybe some incident already happened related to security, right? Fix that. Do something about it. Try to improve pod security. Try to improve network security. Maybe try to review your Terraform script, which sets up the cluster and see if the security groups are well defined. Things like that. Start from small stuff and review like periodically to see if there are any missing items. Yeah.
Okay, great. So here's another poll that we have in there. If you haven't filled it out, let us know. How do you feel about Kubernetes? Are you a Kubernetes pro? Do you feel at home spinning up these clusters? Do you have some knowledge? Do you understand the key concepts, but are still learning? That I think I'm in that category there, where I can say some acronyms and sound like I know what I'm talking about, but when it comes to hands-on ability, I think I'd be lacking. Or is Kubernetes bloody terrifying for you? Let's see how we all feel in the polls right now. So the preliminary results is that everyone seems to have some knowledge. We, about 50%, 49 votes so far said that they have some knowledge. We only have 6 people that think that the Kubernetes elite, and then a lot of people that like me, and a lot of about 21 people so far think it's terrifying. I can relate to that. I'm probably in between those two. But I liked what you said before in the wrap up, because I just want to read it. Don't be afraid. Get going. Kubernetes is a lot, and I think that's, for me too, it feels like so much can go wrong that it you don't even want to start. But I think acknowledging these security issues that we're talking about at Tiexin has given us is a great way to be able to move forward from this, because if we're secure, if we at least have the basics of security, then we can move forward confidently in what we're doing. Now, I just want to remind everyone that if you're watching this on LinkedIn or watching this on YouTube, I think there's 3 people watching on YouTube at the moment. But head over to Crowdcast if you want to ask questions. You got a little bit of time left. I've got the link down there. It's probably in the description of where you're streaming from, because that way you can participate and ask some questions. Now we have a lot of questions to go in here. I do want to point out, if you go into the Ask a Question tab, there's one there from me. I'm curious to know how everyone found out about GitGuardian. So leave a comment and let me know how you found out about GitGuardian. But right now, let's go in and ask some questions here. So we have one. First one here. When you have compliance policies, how do you enforce compliance at runtime? For example, to ensure that encryption for your internal pod communication. Yeah, how do you know whether it's a pod that is not following the encryption channel? Does that make sense to you, Tiexin? Do you have comments around that question?
Yeah, maybe I can answer a little bit. I think this is a great question because a lot of companies has different rules, right? Maybe I can mention two things. First is pod-to-pod communication encryption. Maybe this is what the mutual TLS does. We want the transport layer security. A simple service mesh can enable this by default. So maybe that is one way to go. Another is container runtime security platform. There are many choices, I would say. For example, previously we talked about a little tool called Trivi, which scans Docker images. I remember the company who made that tool is called Aqua Security. They also built a container runtime security platform, which can monitor your workload and traffic real time in the cluster. Yeah.
Okay, great. All right, we have another question here. Is enforcing pod security via service accounts, we have versus cluster role, the new way to go / best practice for securing the cluster?
I wouldn't go so far as to say it's the best practice. I mean, this is one way. Also, there are different preferences for different people, different teams. So pick the method that you feel comfortable with, I think, yeah.
Okay, another question here. Is there a specific tool for security of pods deployment in Kubernetes, like log.trace, .metrics we have in Grafana? So I'm not sure if you're familiar with that tool, but do you know if there's a specific tool for security of pods deployment?
For pods deployment, the container runtime platform can do that, but it does more than that. So I don't know if there is a specific, especially open source tool that focuses on pod security only. Yeah, not sure if that answers the question.
Great. Okay. This one I can answer. Will you share a recording? Yes, we will share a recording. This will be available on Crowdcast after, and it'll also be on our YouTube channel. There's plenty of great content on our YouTube channel around about security. We're trying to expand it out. So always appreciate a subscribe and a like over there. So you can find us by Googling, by just going on YouTube and looking for GitGuardian. I would appreciate you guys joining us over on there. Okay, let's get back to some questions here. If a breach happens and detected, can the pod destroy itself? I like this question.
Can the pod destroy itself? Well, I don't know. Maybe yes, but I haven't seen this before. But I'm not saying this is not impossible. Yeah.
Okay, having a look. What is the best way to allow access to the developers for the cluster and manage RBAC permissions? Any tool suggestions?
Tools, not sure. Suggestions, if we are using like cloud-based services, for example, AWS, we can map different users to different groups, and we can grant access to the group only. I mean, if we have multiple developers, especially tens or even hundreds, if we manage them by users, it would be quite messy. You have a lot of things to worry about, but maybe we can map them to groups, and we manage by group. Yeah. If you are using AWS EKS, there is a config map where you can do this. Yeah.
Okay, great. I'm so glad you're answering these questions. And I'm not here by myself. It's great. It's great information. We're going to try and get as much as we can. We have 23 questions that have currently been asked. So I don't think we're going to get to all 23. But if you look in the questions, what's going to help if you upvote the ones that you like, because then I'm going to have a more chance of seeing them. And we'll do a couple more before we go. Okay. So we have someone here that missed it. Is PSP deprecated only because it's not intuitive to use, or is there a critical flaw with it? So I think an important question is to whether or not we should continue to use PSP or not.
Okay, is it deprecated only because it's hard to use? No, I would say, yeah. Flaws, I also wouldn't go so far to call it as flaws, but in order to improve the usability, the changes are breaking changes. That is why it's not possible to continue building on top of that. And that is why it's deprecated, yeah. At the moment, I think if you are just started, maybe you can get a feeling about PSP. Because PSP basically does the same thing as the replacement, except the replacement is much easier to use. Maybe you don't even need to configure much. It can work out of the box. At the moment, it's beta. Beta, I'm not sure. For a lot of companies, beta probably isn't good enough. So start with PSP first, get a feeling, then migrate, because the migration is supported officially. Yeah.
Okay, cool. So, I mean, it's not like if you're starting to use this now that we then have to forget everything. The tool use is definitely based on the same concepts. That's what I'm hearing, and it's just an improved version of this. But PSP doesn't have any critical flaws that would prevent someone from using it right now.
No, definitely not. Yeah.
Okay, great. Do you have any recommendations for runtime security tools?
Runtime security tools. Okay, I have been using a few. I think there is one from, I think it's called Prisma Cloud. Maybe it got renamed later. Aqua Security has one. There is also Sysdig Falco. I think Sysdig is open source. Falco is a business product around it. Yeah. I have a few experience with all of them. Maybe I can recommend Sysdig, but it's only a personal opinion. Yeah.
Okay, great. I think I'm going to go for one more question. Then we're going to announce the winner of the swag bags here. Okay. I'm trying to find one that. Okay. For a developer, not managing the cluster, but using it and creating namespaces, what would be a good solution to manage external secrets that are not part of the infrastructure, but are needed in the app? For an example, an external API key. Is it okay, for example, to leave them in the cluster and not document in the repo?
Leave it in the cluster, not documented in the repo. I don't think that's a good idea, because in this way you are using the native Kubernetes secret as the single source of truth. And as explained, it's only base 64 encoded. What I would do is to put it in a secrets manager, for example, HashiCorp Vault, and inject the secret into the pod. There are two different ways to inject it. Maybe we don't have time for that, but each way requires some changes to your YAML file. If you don't really want to change anything to your YAML, you don't want to inject anything, maybe try external secrets. External secrets is another custom resource which you just apply, and it can resync the secrets from a secrets manager to Kubernetes. Yeah.
Okay, great. Well, I think we're going to leave the questions there. Tiexin, you have been
What a relief. Yeah.
A world of so you've been a world of help. Okay, so let's have a quick look. We have 2 swag bags to give away today. I think if we're going to keep having, we had 699 people register for this, and 284 have attended have attended live. So I think maybe we need to give away a couple more swag bags in the future, but. We'll stick to this. So we're looking for the people that are most active in the chat and the most upvoted questions. Okay, and we're gonna pull I'm gonna post this name in the chat because I'm really sorry, but I am not sure how to pronounce it. I'll give it a go. So the winner of the first swag bag, Omalaid Akinwum. I'm nearly certain that I've butchered that, and I apologize. But congratulations! I'll email you, and I'll get an address for the address of the swag bag. And the other person who got the most amount of votes on the questions that they asked, Fabo Complani. You have also won a swag bag. Again, I'll post that in the chat there, and I'll be in contact with you. Okay. Ziad. All right. Ziad, we have a form that is in the chat that Ziad has been posting, and I have not been promoting. I am very sorry, Ziad. So before you go, we'd really love to hear about your feedback here. Around infrastructure as a code configurations. So can you please help us out? It will all become clear why we're asking these questions in the future. But until then, it would be super helpful. And finally, too, if there are any further questions, finally, if there are further topics that you would like us to discuss in this webinar, can you put your ideas in the chat? We really want to hear from you guys what information you're looking for so that we can provide that for you. We'll try and find amazing guests like Tiexin. I'm sure everyone will agree that Tiexin was unbelievable here. He answered the most difficult questions we've had on the webinar by far, and he did it without breaking a sweat. So, so thank you so much, Tiexin, for doing that. So please let us know if you want any other types of webinars, and we'll do our best to get great questions for that. Now, I have one other announcement here. I'm just going to share my screen before you go, and that is that Tiexin has a brand new blog on the GitGuardian website, which is 9 Terraform best practices. Now, I believe if it's not live right now, it will be live in a few minutes. But this is a great article. It's not Kubernetes related, but it's from the master himself, Tiexin. So you know it's going to be good. You know it's going to be full of information. So make sure you head over and check that out. You can view that on our blog. It's a blog.gitguardian.com. And if you want to find more, if you want to go through the examples that we've talked about here, then on our blog, if you go to blog.gitguardian.com/Kubernetes, you will find a list of Tiexin's articles that talk about high level and also go hands-on tutorials. So yeah, Tiexin, I personally just want to thank you so much for your participation today. It's been great having you. You're a world of knowledge, and I really hope that we can have you back on the webinar in the future, perhaps with a different topic there.
Thank you. It's my honor.
Yeah. All right, guys, that's all that we have for today. So just to finish up, make sure you check out the GitGuardian blog for great articles. Let us know what type of content that you want, and please jump over to our YouTube channel and give us a subscribe and a like there. We do our best to try and get you the best content for here. So thanks so much for participating. Congratulations to those that won swag bags, and hopefully I will